Hey everyone. So last time we saw how alcohols could be oxidized to give carboxylic acids. We know carboxylic acids are a homologous series of organic compounds which have the carboxylic acid functional group, where the double bonded oxygen and OH are attached on the same carbon. We saw their general formula, which was CN, H2NO2, and there was this other general formula that we also tried. We used the general formula to write the chemical formula of various carboxylic acids like methanoic, ethanoic, propanoic acid, and then later butanoic acid and pentanoic carboxylic acid, which follow the same pattern of homologous series. We know that all the carboxylic acids are weak acids, so they dissociate incompletely in water. The H from the OH part of the carboxylic acid functional group is dissociated and gets a positive charge, while the rest of the molecule, particularly the oxygen, gets a negative charge. So they give yellow color with universal indicator and their pH lies within the range of weak acids. In today's video, we're gonna see the acidic behavior of the carboxylic acids, and we're going to see why we call them acids at all. Imagine we have a methanoic acid, which is one carbon acid, and sodium hydroxide. We know the H from the acidic part is positive while the OH from the alkali is negative. We know that the sodium ion is positive in nature while there's negative on the rest of the acid. So there's a partner exchange. The H from the carboxylic acid combines with the OH from the alkali and it gives us water molecule, while the sodium positive ion will go with the anion of the acid. So H2O is received while sodium goes with the HCOO negative charge, and that gives us a salt called sodium methanoate. Imagine a 3-carbon carboxylic acid and potassium hydroxide. The H in the corner has a positive charge, and the rest of the molecule has a negative charge. Potassium has a positive charge while OH is also a negative charge. Again, there's a partner exchange. The H from the acid and OH from the alkali give us a water molecule. That is neutralization, right? And what happens to the rest of the ions? The potassium positive ion goes to the rest of the carboxylic acid, which is CH3, CH2, COO negative. It gives us potassium propanoate. A 2-carbon carboxylic acid would be ethanoic, and we have calcium hydroxide over here. We again allot the charges. H gets the positive and the oxygen gets the negative, while in calcium hydroxide, calcium is +2 and OH are -2. We do the partner exchange. So H goes to the OH and gives us water molecules, while calcium positive 2 charge should go to the negative ion of the carboxylic acid. But remember that calcium has a +2 and the carboxylic acid ion is a -1. So formula making indicates that the charges are swapped. So the anion of the carboxylic acid gets a 2 within the brackets. So we write CH3COO, but then we put a bracket around it and then we place a 2 outside the bracket because calcium had a +2 charge, and this is how formula making works. Now imagine ethanoic acid and magnesium hydroxide. The H has a positive charge while the rest of the molecule is negative. Magnesium has a +2 while OH is -1. So again, H from the acid goes to the OH from the alkali and gives us water molecule, while magnesium +2 charge should go to the anion of the carboxylic acid. But remember, the charges are again +2 and -1. So we think about the formula making as well, that CH3COO is a -1 and magnesium is a +2. So what do? We put a bracket N2 outside the anion of the carboxylic acid because the 2 from magnesium goes to the anion of the acid, and then we have to use a bracket. Similarly, we can see the balancing that there is one H in the acid and 2 OHs in the alkali. So to balance it, we put a 2 before the acid and it gives us 2 water molecules. Now, if we continue this scenario, we know how the formula making works. Imagine a propanoic acid molecule and now sodium carbonate. We know that H has a positive charge while the rest of the carbon chain gets a negative charge. Sodium has +1, and we know that carbonate is a complex ion, which is a combination of carbon dioxide and oxygen. So when we use carbonates, we should remember that carbonate has a carbon dioxide and oxygen in it. Now let's try the partner exchange, and let's notice that H has a plus charge on it. So where would it go? It would obviously go towards the oxygen. So the H starts, the H plus obviously, I should draw it again, yeah. The H plus goes to the oxygen and H and O combine to give us water molecule, H2O. Now carbon dioxide is a proper product, so it doesn't do anything. Carbon dioxide is already a product. And then what happens to the rest of the ions? Sodium plus goes to the CH3, CH2, COO ion. So it has to be sodium propanoate. We get this over here, sodium propanoate. We balance this equation because we know that there are 2 sodium ions and in the product we had only 1 sodium atom. So we try to balance it. Now imagine we have a 4 carbon carboxylic acid and calcium carbonate. We know carbonates are, a combination of carbon dioxide and oxygen, while the acid has H plus and the rest of the ion is negative. We again combine the H plus with the oxygen from the carbonate to give us a water molecule. So the H from the acid goes with the oxygen from the carbonate and gives us water molecule. What happens to the carbon dioxide? It is released as a gaseous product, while the calcium ion goes to the anion of the carboxylic acid. So C3H7COO has a -1, while calcium ion has a +2 charge on it. So we make sure we work on the formula writing, and the 2, because of the calcium, goes with the anion of the carboxylic acid within a bracket. This is how we write the formula. It becomes calcium butanoate because it's anion with 4 carbon atoms. So every time we make the salt from carboxylic acid, we need to look at the formula. Now imagine, guys, a beaker with a carboxylic acid sample in it and I add sodium carbonate, much like the equation that we did earlier. What would be the observation, guys? So it has to be the bubbling, or you can say fizzing or effervescence, because the carbon dioxide is going to be released. So we can say effervescence or bubbles of colorless gas because of the carbon dioxide. Because every time a carbonate reacts with a carboxylic acid, we see carbon dioxide being produced. And this is a test for carboxylic acids.